And our next speaker is Cliff McMillan from Arab, and I'll try to start the presentation while I introduce you. Skype is off. Who knows who would call it next? Cliff has been a principal is currently a principal with the Arab New York office. Before that, he led their initiative in South Africa, and he's been with Arab for 47 years, which I find absolutely fantastic and remarkable, and just a good sign for our company to keep good people that long. His main focus is on the integration of a lot of the things that we've been talking about in terms of sustainability, the planning, water, energy, waste management at Arab. And he's going to introduce a few of the tools that have developed in-house. He's a frequent speaker at the New York-based universities such as Columbia and Pratt. And we are very glad to have you here. Thank you, Cliff.
Thank you, Christoph. With regard to your introductory remarks, I suppose there is another lecture I could give, and that is Arab is a life sentence. But I've chosen to talk about what we in Arab call integrated resource management. And really, this is in the context of what we, with the very wide range of disciplines that we have, both planning and technical, within the firm, to support the urban planning and design process. And that's what I want to focus on. So we're concerned, therefore, with providing sustainable and integrated solutions related to the resources of energy, water, materials, waste, etc., as well as transportation planning to support the notions of greater access, improved density, mobility that puts the car below issues such as walking, using public transport and cycling. How do we put all those together in the mix and offer solutions and options that can inform the planning process more effectively? Now, we've been involved in this for some while, and one of the earliest efforts some of you may be familiar with was the SPEAR approach, which was developed something like 20 years ago or so now in the firm. And it attempted to provide a tool to visualize all the parameters that influence this intractable process of optimal planning, mainly across the areas of the economic, the environmental, and the social. And the spokes of the wheel would obviously be chosen to be site-specific, and the idea was to quantify each of them for various options in a way that drove the solution towards the center of the wheel. And what we're talking about is a complex series of interactions like that, and that we're trying to make sense of all of that in a way that can not only provide options and optimal solutions, but also ways in which that can be portrayed and visualized. So we refer to a holistic, quantitative model for improved understanding of urban systems and the impact on decisions. So the integrated resource model really integrates the spatial and resource flow parameters that would be associated with different technical issues. So you would start at the top with land use issues and parameters associated as base data with any of the options that you are choosing to examine across all the fields of waste and energy and carbon and so on, and put those into a computer-based system that can generate solutions, options, and means of presentation related to all of the various disciplines that you're involved with, so that you can put a common basis to evaluation of options from an informed perspective of real numerical data, and also use creative people's time at the top to generate the solutions, and that is where the energy needs to go, and not into the enormous amount of time that's involved in working through them and presenting them. And so IRM has now been used in many, many cases to compare baseline design options and design alternatives, to assess different development scenarios, and to communicate the design outputs with carefully designed diagrams, as you can see there, of the different ways of representing the stuff, and also enabling linkage by the planners with tools such as GIS and CAD models. So that broadly is what it is capable of doing. And one example that's quite interesting is the Toronto Waterfront, where we developed a carbon tool specifically for use by the client as the development would proceed. Some of you are aware of the parameters of the Toronto Waterfront. It is a very large residential development across 9.3 hectares. It also is intended to be the home of the Toronto Pan American Games and the village related thereto. And so this is the model as developed there, which has, just repeating what I said before in a slightly different form, a control panel, which is really all the stuff that can be input to the system, the specific baseline options and the various alternatives across the various parameters as the second row, then the process, which is the tool, leading to the outputs in various forms. And that tool is now with the client, and the city actually uses it as a baseline to be used by any developer that intends to operate, in order that the guidelines can be actually applied to the specifics of a development, and also to provide feedback on how the development could be improved. So that is up and running in that context. Now, there's another tool that is more recent, and that is what has been labeled the Hyacinth tool, and is in fact under development by one of our people as doing research work at Imperial College in London at present. And what this does is actually take all of what we've been talking about, but to do it in an optimization way so that you can look at many, many different parameters. And whereas on the bottom left you would you would use IRM just to produce the three different design solutions for three different design densities, with Hyacinth, you can actually put all those parameters into one model and enable it to produce a number of solutions and contribute to optimization across all the parameters. And so you might get, for instance, this sort of output, which is an additional element to it, which is to introduce phasing into the process, so that you could take account of the way costs may be predicted to vary, or policy may be predicted to vary, codes may change, and integrate into it those various changing assumptions, such as building regulations, appliance efficiency, and so on, into the total picture. Another example where the IRM tool was used, and it was our involvement in the competition for the so-called KCARE, the City for Atomic Energy, Atomic and Renewable Energy in Saudi Arabia, that I'm sure some of you in this room had some fun with a few years ago. And without going into the details of the planning solutions, which were obviously about trying to make a demonstration case in that particular unique climate across all the parameters that we've been talking about, from transport to energy to water, etc. In addition to that, to be able to explore design solutions in some of the particular areas, and I'll just mention two of them here. The one is around energy reduction, where particular assumptions were made as regards a base case for commercial buildings, for residential buildings, transportation, industry, etc. And then by applying various design solutions to be able to come up with reductions which could basically reduce the base from about 58 to 22 per person per day. And that was the saving potential in terms of energy. And how that was achieved, really, was to take the typical building base case, and of course that would apply differently to each of the different categories of buildings I was talking about, but take a typical base case building and then look at the energy-saving potentials of a smart design solution. And in this case, the smart design solution, as depicted on the right, was to exploit the very hot, dry climate for its potential to use evaporative cooling to the limit. And by using evaporative cooling, one was able to demonstrate a saving of 77% less energy for a building of that kind. And that was after taking account of the reality that the water that will be used for evaporative cooling will in fact have to come from from desalinated generated water from the coast and pumped up to altitude. But even after allowing for that, a dramatic potential saving. And this depicts the energy story. On the left is just taking the basic buildings and then looking at the various savings, going through more efficient building design, through all the things we've been talking about, orientation and insulation and shading and all of that, down through transportation, through wind generation, and then lower down here in the green part is the top part, the purple part is to do with energy savings. The bottom part is to do with carbon savings, if you like, through using renewables. And the renewables were largely PV because the climate was perfect for it, but also wind and a few other options. A bit about water reduction, which is the other critical resource in many climates. And again, one's talking about taking a baseline case, and in the case of K-Care, a 31% reduction to obtain the actual water demand. And that on the right-hand side shows the distribution between the potable water supply, the reclaimed water, the precipitation, etc. And an important thing to say from that is that there is, of course, a cultural element to how far you can take this, because recycling is the key to it. And it's a cultural question of whether people are prepared to drink recycled water, as they do in many parts of the world, technically totally feasible, whether they are prepared in a country like this to use it for the other bathing needs, etc. That will determine the amount of potable water that is needed and how much of that can be recycled for what permissible uses, including, of course, irrigation down the track. So that was the water story there, and something about the tools that back up IRM in terms of water. That just depicts in a different way the various savings through residential and religious uses, non-residential agriculture, landscaping, etc., and the relationship to the need for desalinated water. So this is the basis of the tool to demonstrate the recycling process, and it really is a means of a spreadsheet-based means of taking all the parameters I've been referring to and working them through different solutions and coming up with ways of site-specific ways of quantifying the different components that can be saved, and also quantifying the means of recycling and treatment that will be applied. And that is just another way of depicting the way in which the output can be presented to make sense of a fairly intractable issue, so that decision makers can look at the total picture and be able to make informed decisions. this is the same applied to the water harvesting aspect of this, which is very important in so many sites and which one tries to exploit to the maximum wherever possible. And this is just the tool that goes behind determining from the rainfall pattern, from the annual demand pattern, what capacities will be needed for storage of the water in order to be able to use the harvested water for what proportion of the total demand through the year. So moving on to something rather different now, and that is a tool that we have called for pedestrian planning called mass motion, which has been around for some while. It is a tool that can be used, for instance, in an example like this, which is a university building that is to be used for in a high-rise situation. And the challenge here was the number of pedestrians coming and going at a certain time around 6 o'clock in the day, where you've got people coming in and people going out, and the most concentrated arrangement. And what does that do to turnstiles, to management people and processes needed at the spot, and so on. And this is able to take all of that data and run it at different times and examine the queuing, the process of movement, etc. Similarly, with the increasing development, in this case on the west side of Manhattan, where some of the streets are being pedestrianized and others will become increasingly busy as the developments that are proposed for the west Midtown will take place. This is examining what happens at street intersections and what are the pedestrianization challenges that go with that. And it's able to do cool little things like that, and you can see what happens. But you can see the time ticking and the actual numerical side of it. It's a very numerate tool. It gives you outputs that can be used for real planning challenges. Fulton Street Transit Center, which we've been busy with for, I think, 12 years, and is going to open next year, I'm assured, was a really interesting challenge 10 years ago to using mass motion to depict what was going to happen with pedestrian flows, turnstiles, and so on, in a situation where really the fundamental reason for Fulton Transit Center is about integrating people who were going in many different directions to many stations, all of which are close together at that part of Manhattan. And by creating this large hub as a center for it, allowing daylighting right down to the platforms and all to create a great space, you had this concentration of pedestrians that you had to evaluate. And of course, the tool can be used for many, many applications, like, for instance, also in risk assessment of people, in this case, escape from a high-rise building or escape from a fire situation if our fire engineers are working with it. So that really is all I have to say, is just to give an overview of the sort of tools that can come into play to be an aid to understanding what is going on there when we're trying to grapple with these complex number of parameters and get our arms around them to come up with good solutions. Thank you.
Excellent presentation. Thank you. We have time for questions.
Well,
there's a question over there. You said it all.
What is, like, the RMI tool you presented, what is kind of the typical project you would assess? Would it be a university campus or a master plan?
The one with the students.
No, the resource management integration tool.
Yes.
Like, what is the ideal project to use that for?
I think it could be used right across the board, really. I mean, obviously, if the issue is quite simple, you can get your arms around it without needing a tool like that. But generally, we are really trying to look at all those different parameters in harmony. And in the end, it's a case of where do you want to spend your resources? Where is your maximum payback? And how are you going to make the most impact, either be it on carbon or be it on conservation of precious resources like water. So obviously there will be differences, as everyone in the room today has said. It's very climate specific, it's very location specific. But I think the tool is a valuable tool for more or less any of those kinds of situations which are very multidisciplinary and have many variables.
Just maybe as a question to get a better sense of the tool. The tool looks a bit like a spreadsheet approach, as you said,
yeah.
But are you running the engines automatically out of the spreadsheet, or is it a process where you have the different groups running?
It's very linked. Yes, it's very linked. I mean, it's a very multidisciplinary team that's working on this. Sometimes in different offices and all specialised in those different disciplines. Mm-hmm. They're applying their energies to their specific disciplines to come up with the parameters, with the options, and so on. That doesn't change.
Okay.
The issue is how to feed it into and get a comprehensive picture out of all of that. Otherwise, one ends up looking at it often from a very biased perspective.
The Hyacinth tool that you mentioned optimization with that, and I'm curious, so that's a term that gets thrown around a lot.
Yeah.
And what I'm curious about is, when you use it, are you talking about automated numerical optimization and evolutionary type algorithms and so forth, or is it a sort of a manual, iterative kind of optimization process?
Okay. I should have said by introduction there were a very large number of my colleagues that I should thank for putting this together, which is code for saying, don't ask me probing questions. but having said that, I think I can say that one is talking about optimization only really in the sense of being able to run through a significant number of cases. So it is a sort of quasi-optimization.
Other question from you?
And is the mass motion software, is that available only through Arab consulting contracts, or is it more generally available?
I think that yes, it works through us. I don't think we've marketed it or anything like that, not yet anyway. Although there are others of our tools that I hesitate, because we do have a number of tools that are out there through various means. But I think mass motion at this stage is only in-house. Yes.
There's something that looks a little bit like this that IESE seems to have brought out in their latest demo. There's something like this, and I think Couple has something like this, Rhino-based as well. And the physics might be different, but the general people movement is a lot of it. Okay.
When you get involved in a project, how early do you start? Do these tools get used in conceptual phases, or does this wait until the building plan is mostly finished?
That's a good question, and of course our normal answer to that, whether we're designing a building or involved in a planning study or whatever, would be as early as possible. Because really, you want to, it's a team effort, as with anything like this, and you don't want to come in spoiling the show after a lot of energy has been and emotion has been invested in particular solutions. So it's sitting around, the notion of sitting around the table with a more or less blank piece of paper is a good one. That said, of course, we're relying on a lead designer, a lead planner, and that is normally not one of us. There are variations on that, but let's assume it's an urban designer over there. We're expecting that there will be a leap to that there will be something tangible in terms of the thought processes and the objectives and how the client's brief is going to be interpreted and that sort of thing. So I don't mean a totally blank piece of paper that you sort of fill up by cranking things through a computer. It needs cohesion, it needs a design leader, it needs a conception that is holistic, into which we can all feed.
That was a very important thing, comment, I think, that how important it is that we have strong design.
Collaboration and teamwork.
Thanks, Cliff.